Welcome to the IEEE Artificial Intelligence webinar, sponsored by IEEE Maine section, Communication Society and Computer Society joint chapter, and hosted by the University of Maine. My name is Ali Abedi, serving UMaine as Associate Vice President for Research and IEEE as Vice President for the Council on Radio Frequency Identification. It is my great pleasure to introduce our speaker today, Mr. Zac Canders. Zac Canders is co-founder and co-CEO of DataCapable. He lives in Bangor, Maine, and is a longtime advocate on the usage of AI for public safety and infrastructure resilience. Zac holds a project management professional certification and an MBA with 20 years of experience in utility industry. He has worked with many of the world's biggest consulting organizations, such as Accenture, Deloitte, Leidos, Oracle, IBM, Tata, Infosys, KPMG, Ernst & Young, and Boston Consulting, as well as major utilities and suppliers such as PG&E, SDGE, First Energy, Hawaii Electric, Southern California Gas, Duke Energy, CPS, and Centerpoint. Please post your questions in the Q&A box, and we'll answer those after the presentation. This video will be recorded and posted on UMaine AI website in the next couple of weeks. And before we start, I would like to thank IEEE collaborators we have across the globe in Silicon Valley area, in Boston area, in Bangalore, India, and Shenzhen, China for promoting this talk. And without further ado, I would like to invite Zac to start the talk.
Thank you, Ollie, for the introduction. I'll get my screen on share. Just confirmation, everyone can see that, correct?
Yes, perfect.
Perfect. Yeah, so I guess first to get started, I'd like to thank, obviously, the University of Maine. Being a Mainer myself, living in Bangor, Maine, helping to grow innovation in the state, it's really great to have collaboration with the university system. You'll have my email at the end of the presentation. Feel free, anyone that's here today, to reach out, say hi, stop by, visit us. And then the next part is thanking IEEE. IEEE is going through a rebrand themselves, focusing on the role of collaboration. It's amazing to be part of the IEEE family. For the state, I actually serve as the editor or co-editor of the Beacon. So very passionate about the vision and the mission that IEEE has, and also how it's bringing university and other vendors like ourselves to the table for this collaboration. As you look to the future, right, University of Maine is well positioned to be a leader in artificial intelligence and a continued leader in engineering. So it's super exciting to be part of this series of webinars. And ultimately, myself included, I've been a huge advocate for the use of AI, but even more so the use of collaboration. About 5 years back, wrote this white paper. It was titled, "I Want My Toaster to Talk to My Utility." The whole concept was there's all these systems and signals, and how do we take this data, all this data, and do something with it? And not just do something with it, but enable this whole new realm of collaboration. That collaboration can't happen without the involvement of the university systems, vendors like ourselves, and IEEE. I'm a firm believer in that. The other key piece to that is the team. So unfortunately, today, there were supposed to be 2 other speakers with me. They have a conflict with one of our customers. One of those is Justin Nordstrom. Justin leads our software development team. He's an expert in development technologies, really great individual, and his contact information is provided as well. The other one, which is super exciting, is Katie Desjardins. Katie is actually an alumni of the UMaine system. She's currently going for her PhD. She leads all of our customer success activities. So Katie's focused on making sure that while we're developing and building all this really interesting technology and capabilities, Katie's role is to make sure that you can actually translate technology in usability and actually generate value at the places that we work. So they're not here, they're here in spirit. And a lot of what you're going to see today comes from all the great teamwork that they provided to this. For the presentation, we've done our introductions. We're going to talk a little bit about the company, our role in the state of Maine, our role in innovation. We'll go into a little bit of a technical discussion, go through how AI is actually adding real value for public safety out there in the United States and abroad. We'll talk a little bit about the future, where we kind of think some of these things are headed. And then it's time for question and answers. As Ollie said, post your questions in the chat, and then at the end, we'll circle back to all of those. So if you've been following this webinar series, I love a story, the evolution of things. There was a presentation in April, and we had two presenters, right? It was Pinder Van Aman, and who's an AI artist, right? At the time, that sounded crazy, an artist specializing in AI. And then we had an assistant professor at the University of Maine. His name is Vikas Diman. What they talked about was that AI is going to be better than humans when it comes to art, right? And if you were here on the webinar, you probably said, well, this is crazy. I did. I actually texted Julia, who's the president of IEEE Maine, and said, that was cool, but I don't believe it. I'm eating my words today, right? Like we're living the evolution of AI. 2 days ago at a state fair, AI won the art contest. There's a picture of it right there. It took the gold award. And now artists are mad, right? They're mad that the machine is creating more creativity than they did. And they're demanding that there's a separate category for AI versus what a human can create. So I guess as you go through these slides and you hear what we're providing to industry and what we're thinking about, kind of think about that this is evolving. This is a whole new realm of science and technology and collaboration, and it's changing just as fast. So who is DataCapable? Ultimately, if you're an entrepreneur on the call, DataCapable is a team, right? You can build anything. You can build technology. You can solve really interesting problems. You can generate these amazing businesses all over the world. But if you don't have a team, you don't have really much of anything to stand on. So at our core, we're a group of professionals that really believe in the concept of a team. We're proud of the people that we work with, the communities that we serve, the customers that we provide this situational awareness with. And ultimately, it's a bunch of folks with diverse backgrounds. We've got teammates from the military, we've got engineers, we've got AI specialists and software engineers. And how we came to be is kind of unique. So myself and our other co-founder, Peter DeSalvo, we've been good friends since college, believe it or not. And during Superstorm Sandy, which was 2012, we saw the crisis, right? You had massive destruction on the East Coast in New Jersey and New York. You had individuals without power, but you were also seeing this cusp of data. Like it was just oodles and oodles of information about where there was damages and where there was floods and where people truly needed help and emergency response resources. And what we realized is that something needed to exist to kind of align all of this information that could be quickly repurposed. And so from that day, 2012, the company was born. Since that time, we've grown up quite a bit, and we've got 3 different unique products that we offer to the industry. So for today, we're going to focus on the role of AI, and we're going to talk about what we call Threat Detector. Threat Detector is basically a software that helps emergency response and public sector officials understand when, where, and why bad things are happening. Complemented to that is a tool called the Outage and Event Map. This is used by millions of customers across the United States. What it is, when your power goes out, you can go to a map and you can see when, where, and why your outage is happening. And then you can get more information from the provider of your electricity. And then our third product is the Community Portal. Community Portal is really essentially a secure environment to share more information with regional officials, so safety, police, fire, government, to know when and where things are happening based on the utility and other emergency responders that are supporting the restoration, the recovery, the resiliency, and the rebuild. Along the way, right, when you look at these 3 core platforms, you might hear some like terms like SIGING, so signal intelligent, or OSINT, which is like open source intelligent. Ultimately, right, it's a combination of a lot of industries and capabilities that are really empowered by what I think is 2 things. So the first is we've got Moore's Law, right? So Moore's Law says that the number of transistors that exist on a microchip is going to double every 2 years, right? And the cost to compute to actually do this is going down and down and down. And since the law was pontificated, it's proven true. And then you get the second thing, you get this thing called Metcalfe's Law. So Metcalfe's Law, again, it's a concept, but what it says is that in computer telecommunication networks, the value of a network is impacted by the square of the number of nodes. So essentially, the more things you have on a network, the more communication you have, the more compute power that you have, the more things that you can do, right? But those two things together, they don't solve the bigger question of how do you do something with it? Like you're talking just oodles and oodles of data. So to take that next step, right, the big scary next step, it's artificial intelligence, right? So what is AI? AI to us, it's technology that enables machines to behave like a human when it comes to how it reasons. And when you think about AI, it's a very broad subset of algorithms and technologies. You have deep learning, machine learning, but essentially the goal is for it to solve complex problems in a human-like behavior so that you can actually do something with that combo of Metcalfe's law and Moore's law. So that's what we at DataCapable embraced. And then the value is basically spoken to on this slide. We work with multiple different sectors, from transportation to energy to emergency response to the national labs, bringing the power of AI to a real life working environment. And why? Well, the answer is, if you go to a conference, right, and you walk the floor, it doesn't matter what industry you're in, if it's products or energy or science or medicine, you're going to hear things about sustainability and resiliency. And so as you think about where the world is headed, right, you're seeing catastrophic events related to weather. Look at the flooding in Pakistan that's happening right now. These events are growing in the frequency and the veracity of the events themselves. And when you combine that knowledge with the sensors, with the communication, with the data, obviously emergency managers need something in their tool chest to react quicker, to understand what's going on faster, to get resources to the field, to ultimately help resolve whatever these events might be. And coupled with that, right, so if you look here in the state of Maine, the Maine Emergency Association, MEMA, these are things they're challenged with every single day. Budgets are always a constraint, right? They've got all kinds of these sensors and information and vendors calling them and saying, hey, use this widget, do this thing. But how do you know what to use and what not to use? And then you have this dynamic change of where people work, right? Most folks now are working from their home offices. I know I am today. So how do you take all these major challenges that you're seeing from these folks that ultimately help get power back on, help people return to their jobs, help make sure that the roads are cleared? We're one of many vendors that support this ecosystem. So what I'm going to now talk about is a little on the AI, how we use AI, and the technology aspect to it. So what is Threat Detector? Threat Detector for DataCapable is a tool set that provides situational awareness across the US on when, where, and why events are happening. And these events are detected using artificial intelligence, and then they are provided back to system operators to then react based on those things. And if you went to the Facebook page, right, for this whole event, IEEE Maine had a post and it said, what does Die Hard or the Nakatomi Plaza have to do with AI? And if this was a collaborative session, we'd go around the room and I'd say, hey, what do you think it has to do with it? We get all these funny answers, but I'll tell you what it has to do with it. So on December 25th of 2020, I received a phone call from a government organization that we support that said, you need to fix an algorithm, an AI algorithm. And the reason why we need to fix that algorithm is because the algorithm, the AI, thought there was an active shooter at the Nakatomi Plaza. Now, every Christmas, the AI thinks something's happening at the Nakatomi Plaza. And there is something happening. It's Die Hard, and people are watching it because some folks, I'm not in that bucket, think Die Hard is a Christmas movie. But that algorithm, as it's monitoring internet traffic, it sees it and it thinks, yes, this looks real. It passes all the checks that AI needs to check. So when you think about algorithms, right, you might have the world's best algorithm and all the categorization things we're about to talk about in like 2 seconds. Just remember, the algorithm can get things wrong, and you have to always be thinking, what's next? How do we develop that next piece of code to solve that problem? What do we detect? So daily, these types of events on the screen are provided back to emergency response and public safety officials across the country. And each of these events are trained individually on how they are talked about across the internet. So there's keywords and there's patterns in every single one of these that have been modeled to quickly identify when this type of thing is happening. So think about structure fire, right? There's the way I would describe it. Oh my word, look, there's a fire outside my window right now. But then there's also, well, I don't know, the Bloodhound Gang where they sing the roof is on fire. That's not a structure fire, but it sure sounds like it. So being able to detect and analyze based on the commonality of these events, that's part of how this works with AI. And so from a workflow perspective, this is what we do. 24/7, we're monitoring data streams. And then the algorithms are parsing out the noise, right? The things that just aren't real events. And then a human takes a look and says, hey, did it get it right after all the analysis? And then at that point, it's gone through machine analysis, human verification to client value. And so the first part of that process is the filtering. Filtering, right? So lots of sources, right, have the ability to be data mined. And when we're data mining these sources, we're identifying keywords, right? Like the phrases, right? But just because you identify a phrase doesn't quite mean that you've caught all the ways that an event can be described. And it also doesn't mean that you're necessarily going to capture the true story of the event. So then it goes to this next thing called categorization, right? So what categorization does is an algorithm is trained on previous events, right? That's the machine learning aspect, the AI aspect of what we do. And then these events include keywords that are most likely to be part of the event. So the category, somewhere in there, you're seeing that category, gas explosion. But then just because you've captured the category, right, it doesn't mean you've seen really what's happening, right? So let's go back in time. Let's go to December 25th, again, 2020. A gentleman down in Nashville exploded a truck in front of an AT&T facility. And when that explosion occurred, you had multiple categories of events, right? So you had explosions, you had fires, you had structure fires, and you even had power outages. On top of that, you don't usually see trucks exploding, so you probably have maybe some sort of domestic terrorism type of thing happening at that point in time. So the algorithm might say, well, there's this event, this event, this event, this event. Which event is it, right? Maybe it's all the events. So after you do the categorization and the filtering, you go into this concept of probability. So what probability does, it's the same technique, right, using AI, but this is where a score gets attributed based on the historical similarities to what's being described. So in this case, you're looking for things like tense of the way it's being posted, right? And you're also looking for the construct of the verbiage to make sure that it's consistent with things from the past, matching what's being talked about in the now. And that's a recursive algorithm that's always running, trying to improve itself and get better and better and better over time, so you don't get these false positives or noise we talked about before in the data set. So if anyone remembers what happened in 2013, Beyonce and outages. So every year when the Super Bowl rolls around, you have an outage. Well, you don't, right? You have the past tense of an outage. People like to talk about what happened. The Superdome lost power during the halftime show for 33 minutes. Now, what's interesting about this power outage is that it was actually not Beyonce's fault. It was a switchgear. The relay settings were not set correctly. But number two, people still talk about it like it's happening now, and or they use that past tense. So you always have to be catching those things and making sure that you ignore them so you don't report falsely that this event's happening now. And then the final part in this puzzle is location. So location is the key component of what we do, right? And location is a very interesting thing, right? Because we all describe location differently. My home is different than the location of your home, but we both say it's my home. When you think about when we receive location posts, there's a couple different ways that you can attribute it to where it might be on Earth. So some things are metadata, right? Metadata is that when you take a photo or an image or a video, buried inside all that data is the latitude and longitude of where that information was taken. That stuff's great. But the second thing is, a lot of times people just describe location, right? They'll say an intersection of a street or a spot on a highway. So part of what the algorithm does now is it says, well, where is this location out there on Earth? And it tries to match it to a true latitude, longitude. And then part of what has to happen here is that the AI has to be smart enough to programmatically deconstruct the message, pull out things that look like location, map those things based on a library of all facilities and places and geo-encoded locations across the entire country to say this thing is happening right here automatically. And at that point, this is where you're able to start to say, hey, there's something happening in this location. But again, there's limitations, right? So now we've gone through the whole AI workflow and out pops an event, right? So think about this. Someone could say from Boca Raton, Florida, oh, wow, look at this mudslide. And it's your Uncle John sitting there holding a mudslide, sipping on it on his vacation, right? Or they could say, oh, wow, look at this mudslide. And it's a mudslide out in Northern California in the mountains that's impacted gas lines and transportation roads and all that stuff. So they both say the same thing, but they're two different images, right? By being able to analyze what's in the imagery, and then also being able to analyze where are they reporting this thing, helps to start to figure out, well, is it really a mudslide? And then the other part is, how do you then verify it, right? So we're gonna come to verifying in a second, but just keep in mind that just because the algorithm went through all those things, it doesn't mean that it's perfect. So this is how we solve the problem. We bridge the gap by looking at the posts that come through with a human. So all of those things that happen then have to get verified. And that's the limitation right now that we're seeing with AI, is that you can work all the way through the workflow, but a human still needs to be there to prevent those false positives. And the goal for us as a company is we just want to make sure that the emergency response officials and the public safety individuals across the country don't get inundated with bad data or events that don't exist. And so that's part of the process. But the next piece is, well, how do you follow an event? How do you update an event? How do you monitor an event? So at this point, what we've done is we've gone through this, hey, you've got an event. This is where the human comes in and starts to add more details, more imagery that you can find out there, things that you hear maybe on a police scanner or you find on a data source that can't be programmatically modeled. Contextualization is the word we choose at DataCapable for it. Essentially, it's just inserting an analyst in the loop of these AI-based events to make sure that, hey, the data package is well-rounded and folks can actually do things with the information. Finally, what does this mean for the future of AI? So there's a lot of ways we can improve and the industry can improve and other folks can improve. And one of those things is the human in loop, right? So the human in loop can always get better, right? More details, more information, making sure that false positives don't get out there. The second thing is more data. So there's oodles of data that even today for our company, we don't use and we don't analyze. Think about something like your Nest thermostat, that controls the temperature in your house. Those things are tracking things like the power outages that happen because they're internet connected. There's all these other data sources out there that we could apply these AI algorithms to do really spectacular things. And then the other part to that is, how can AI actually support AI, right? So there's a couple terms that are showing up, AI on AI or recursive AI. Essentially, all people are thinking about is, well, what if we could take those events that have been validated by AI, and instead of having the human then do the verification and check, let's put another AI algorithm on top of all that AI to spit out something that might be the actual same thing a human might do. And then finally, how do we take these static events? There's a fire at this location, and then overlay assets that might be able to move. So the concept there is, you have an event, it's a wildfire or an active shooter, but you have people that might drive through that event. How do you notify anyone in those perimeters that may intersect the perimeter of that event? Hey, don't go there. So there's lots of things that can still happen to make this even more interesting and value add with the use of AI. But what does it look like in a day in the life? So day in the life, our goal at DataCapable is to make sure that real-time information is provided to our customers based on these events. And so these can be given to the end user in a variety of mechanisms. So one of those mechanisms is the software, right? You log into a portal, the platform, and you can see where in your area of interest are these events happening. And that's one way to work with data. The other way is the programmatic access and usage of data. So in this example, we also provide data via what's called an API, a automatic program interface, and or something called an Esri feature service. And all that means is that our data is extensible to other applications. We can expose this info and let it be used in other places. So while it's still the exact same information, you're not actually stuck on having to be inside the platform we created. You can use it wherever you'd like to. And that's one of the trends that I hope I leave for the, the new students on the call and others, is that if you're building something that's data driven, make sure that you can get that data from your application into other areas so that the value is just compounded. It's that Moore's law and Metcalfe's law and AI all coming together. Don't just constrain your end user to working with information in one spot. What will happen on the back end is once we detect these events, email, text messages, screen pop-ups, the typical things you'd expect are sent out to the customers that we work with. They see these things in real time. And then ultimately, this gives them the way to interact with the data and make really quick decisions on what to do. And then finally, you have that continually monitoring, right? So it's not just the, hey, there's an active shooter at this location. It's there's an active shooter. It's in this perimeter. This is what we're seeing. This is the population in the area. This is the law enforcement response, so that emergency response officials know up to the minute what's going on. And then on a success standpoint, so I mentioned in the beginning, we are the customer-facing map for a lot of utilities when power goes out. One of those utilities is called Entergy. Entergy is a large investor-owned utility located down in Louisiana. Heavy hurricane-prone region. And one of those hurricanes was last year. Ironically, it was on September 1st of 2022. 2021. I'm losing track of my years. So September 1st, 2021, this hurricane makes landfall. It was known as the most destructive hurricane. Second most. It's very close to another one down there, but second most damaging to the state of Louisiana. But when we look at what happened next, it's unbelievable. So that hurricane basically tracked all the way from Louisiana up to New Jersey before it went up to the coast. For us Mainers on the call, you probably remember we had big rains on September 2nd, some local power outages in the region. When this storm hit, we were providing information to partners across the country, and that included things like the location of some tornadoes that broke out, the location of major flooding, the location of major transportation events or road blockages. And what that did, that added real-time value to the emergency response folks across the country that use this information. Unfortunately, across the storm, there was 107 deaths. 87 of those were in the US. The remainder happened outside the country. And they were all really attributed to the flooding that happened in the Northeast, right? So a storm in the South caused massive damage all the way up in the Northeast. But as you kind of heard me say, the data that we provided did help folks. Another example would be like wildfires, right? So how is AI supporting wildfires? So by providing early indication of where a wildfire has been detected, what our company's been able to do is support folks and utilities out in the Pacific Northwest and South, obviously all on the coast of California, with this real-time awareness that wildfires are happening. So if we go back in time, 2017, California had some major fires. In total, there were 22. The one that everyone really seems to know about would be the Tubbs fire. Hundreds of thousands of evacuations occurred, like almost 10,000 structure fires, homes burned to the ground. During that time period, we were providing real-time analysis of the assets related to the companies we work with, were those assets being impacted by these major fires. And the response is kind of listed up here, but they were moving their crews, their people out of harm's way in real time based on the movement of these wildfires. And then finally, I hate to end on a sad note, but active shooters. So this number, it's going up. If you look at more holistically as like mass shooting events, there's about 15 that happen every single year. In 2022 alone, there's been 410 of these events. Those have resulted in over 500 deaths and close to 2,000 injuries. The active shooter capability we provide is essentially when we detect one of these events, we notify our customers, and then that allows them to, again, move folks out of harm's way. We've got numerous examples where, you've had crews working in the field that are near either a school or a facility that's being impacted by one of these events. By using a service like this, they're able to then know, hey, I need to leave this area. They're dispatched out. Police are able to do their job and ultimately create a safer environment when these things happen. So those are some real examples that are being used on a daily basis by folks in public safety. With that, I get to the final part, which would be my question and answers. So Ollie, I think I turn it over to you.
Thank you very much, Zach, for making very complex concepts sound simple for us to understand. So you did a great job presenting this. We are really appreciative of you being here. So let's get into the question and answers. We have a few questions already posted in the Q&A box. So the first question is from John Zittel. Could you comment on the timeliness of the alerts that you get from this methodology? It would seem that you don't get an alert until information about the event becomes widely available in the data streams that you're monitoring.
Ooh, great question, John. Yeah, how fast? So these algorithms are running in real time. So essentially, as fast as an individual can get that data source to the internet and we can detect it, all that from the detection, analysis, filtering, location attributed categorization, and it's there as an event, that happens in sub-second. And then and how does that happen, John, is while we're using cloud technologies with a really high volume of compute to be able to perform those tasks like ultra fast. And then post that, we do make the data available to customers as a non-validated event should they want it. But typically what we do is we work to determine how quickly does the end user need that review, analysis, and sharing of the details of the event based on the criticality. So for each of those use cases that I described, there might be different deltas in the true detection of the AI versus the human versus the visibility in their own operating environment. So high level, I tell you, it's about 2 minutes on the lineup, but it can be faster based on the criticality of it.
Thank you very much. So the next question is from Alba Gabriela Garay Romero from Honduras. So the question is that, how do you use geospatial data to reduce the uncertainty of an identification? For example, in the case of the mudslide pick.
That is a great question, because I know Honduras does have a lot with weather down there too. That's cool that you're here today too. Thank you. So when you look at geospatial, it's a huge umbrella. One thing I'll mention to all the folks here, because I know we got a lot of entrepreneurs, spend some time reading up on geospatial technology providers. One of those is a really great partner of ours. Their name is Esri, ESRI. When it comes to geospatial, there's a lot of tools and technologies you can use right out of the box to verify and understand location. One of those things is libraries of addresses, right? So what we're doing is we're consuming geospatial libraries, how people have called these assets, right? So in Bangor, Maine, there's Tri-City Pizza. Tri-City Pizza is a known location. You also then have things like the address of Tri-City Pizza. Those two things are different, but they're related. So syncing those libraries is some of the stuff that we do. And then ultimately, when you look at the metadata, because I know you said inside the image, there can be issues with metadata, and we try to account for that. But ultimately, that gives us a start. And to round out the question, sometimes you just can't attribute location. Someone might say on one of these platforms, "Hi, I have a power outage. What do I do?" Those are like floating points, and they're really hard to identify. You know something's happening somewhere. One of the things that we will do, though, is say we can't get location perfect. Someone says, "Well, I've got a power outage in Bangor, Maine." Well, Bangor, Maine's a pretty big piece of land. But then we see another post says, "Oh, I've got a power outage at my house near the high school in Bangor." You're getting closer, right? So you're starting to map that down. So we do look at the frequency and the details to try to say, well, that outage and this outage, they're probably related, and this is probably the perimeter of the event. I hope that answers your question.
Thank you very much. And that actually is a good segue to the next question. This is from Asif Nawaz. Where is the data coming from, and how reliable is the data?
Hey, great question too, because we did not cover that. So we're using open source platforms, right? So that I remember said in the beginning, the OSINT capabilities, but we can also use data from our customers as well and apply the same algorithms. So When we look at how and where we're getting our data sources, we're using a whole bunch of variety. If we talk about the utility industry, specifically, some of that comes from applications like Twitter, but some of it also comes from their own applications where people make reports via the website. So we try to use really whatever we can get our hands on, apply those models to the actual use case that we're trying to detect, and then report back. Other examples, there's these things called community alerts that are out there. There's police and fire data feeds that are out there. There's websites that post a lot of information like this. So really anything that we can get our hands on to identify where events happening.
Thank you very much. And that's all the questions we had for today. I want to thank our speaker again for the great presentation, and also bring everybody's attention to our future webinars. Our every webinar is always the first Thursday of the month. So the next one is coming up on Thursday, October 6th on Secure AI webinar. We have a speaker from Carnegie Mellon University and another one from Santa Clara University talking about trustworthy online social media and software assurance and AI education. And also our November AI webinar is on Thursday, November 3rd. And that's about technology predictions, art, science, and fashion by the director and distinguished technologists from HP Labs. So I would like to invite everybody to check out AI Human webinar and sign up for those. So without taking too much time, before we close the presentation, I just want to thank IEEE Maine section, IEEE Communication and Computer Society chapter, as well as our colleagues in IEEE Silicon Valley area, Boston area, Bangalore, India, and Shenzhen, China for promoting this. And again, thank you very much, Zac, for the great presentation. Looking forward to seeing more success coming out of DataCapable. So have a great day, everyone. Thanks for joining us.